All right, so so it's next month's balance is 1.002 times the current balance. And we've got to find the percentage increase each month and explain why the balance is an exponential function of time. Okay? So there's a short answer and a long answer. I mean, the short answer is that we keep taking... so each month we're multiplying by this, and that gives us the same amount plus a percentage. And so the very short answer is, look, 0.002 as a percentage is just move that decimal point over 2 spaces, 0.2%. And so if we keep multiplying by this every month, we are getting the same amount back plus 0.2%. It's increasing by 0.2% each month. That means we have exponential growth. So that's the short answer. Because we have a percentage increase. What's that?
Where does the 1.002 go?
The one, you want to get you don't want all your money to go away, right? So you don't want to multiply by just 0, because then you'll just get the interest, but you won't get your money back. So the 1 is your money in your account. Like if you put $1,000 in an account, you want to keep that money and get some interest on top, right? So that's the issue. So you can't just multiply by 0.02 and get the interest and then lose your $1,000. Like you have to keep that. The whole point is to keep the money you put in there and get interest on top of that. So that's where the 1 comes in. Yeah, but I'll make up some numbers and see if this makes sense. So we'll look at this. We'll start with a month and then we'll look at the balance. Right? So month 0, let's put in, I'll just make this up, $10,000 into an account. Okay? I just made that up. This is all made up, but I'm just doing it to explain the problem. After 1 month, what is going to be in the account? Can you figure that out? So the next month's balance is this number times the current balance. So see if you can figure out what it should be.
$10,020.
Right. So it's this number times the current balance. So we take our 10,000 times 1.002, because that's what I told us to do, and you get this. Now, looking at the 10,020, there's 2 numbers. That is composed of 2 things. It's composed of a $10,000 amount and $20. Which is the initial investment and which is the interest?
10,000 is the initial.
Good, and that's why we had the 1 there. Because if you multiply by 10,000 by 1, you just get 10,000 back, and the 0.002 gives us the 20, right? So that's our interest, right? Now the trick is, and the reason it's exponential is, here's what is not going to happen. Every month, we're not going to just add on $20. If we just added on $20 a year, does anybody know what that type of interest is called if you add on the exact same amount each month? Sorry, not per year, but per month. It's a type of interest. And you know? So two types of interest in the world is simple interest and compound interest. Now, if you just add on the same amount of money each month, that's called simple interest. Does that make sense? Did you ever hear that? We'll see it in chapter 4. But adding on the same amount of money each month is simple interest. And that would be actually a linear function because you're just adding on the same amount each month, right? So linear straight line is just the same amount each month, right? But what we're going to see is the next month, can you figure out what should be in the account? So take your time. What should be in the account at the end of month 2? And it's not going to be just adding on $20. A little bit more complicated.
$10,040.04.
Right, right. So our rule is the next month's balance is this number times the current balance. So we can take what it was before, which is this, and we times it by this. Does that make sense? Because that's what it told us to do, right? In other words, you're getting 0.2% interest every month, right? That's your kind of monthly interest rate, right? And if you get that, it's stick that in the calculator and you get that, isn't it? Right? Which, look at that, you got 40 cents. You didn't just get another $20. You got an extra $20 and 40 cents. See that?
4 cents.
And sorry, it should be 0.4. Yeah, I can't do math. Let me get a new job. 4 cents. All right. So you don't just get an extra $20, you get $20 and some cents as well. So that's why this is called compound interest. This is called, you'll see that in chapter 4, compound interest. Because you're getting interest on top of previous interest, right? And in fact, there's a nicer way to do this, which is we started with 10,000. For the first month, we multiplied by this. And then for the next month, we multiplied by this again. Remember that? Right? And there's a cool math way of writing when you have two numbers multiplied by each other that are the exact same thing. Now, everybody write this down. Don't shout it out. But what's the math way? If you have like 5 times 5, that can be written 5 what? Or if you have like x times x, that can be written x what, if you can remember. Cool math way for simplifying when you multiply two numbers together. Write it down. Don't shout it out. Just write it down. Just write it down. Do we all get it? It's just a squared, right? Or write this down for fun. If I've got y times y times y times y times y, I got 5 of these. How can I simplify that? Just write it down. Don't shout it out. Y times y times itself 5 times would be y to the power of 5. Good. So that comes up a lot in this class. So here's like the second month. You've got the 1.002 times itself twice. So that can be written like this: 1.002 squared. A little squared there, right? So after 2 months, you get your initial investment times this squared, and that's a cool formula. That's the compound interest formula that you will see in chapter 4. We do it over and over again. So after 3 months, you take your initial investment, you multiply it by 1.002 for the first month, and then 1.002 for the second month, and 1.002 for the third month. And the easier way to write that is just take your 10,000 and multiply it by 1.002. And what should the exponent be?
3.
Right, because there's 1, 2, 3 of them, 3. And that's the cool math way of doing it. And in your calculator, that would be, 10,000 multiplied by 1.002 to the power, little hat sign, 3. And you can just plug that all in as a one-line entry. If I could find my calculator, I could do it too. But anyway, 10,000 times 1.002 to the power of 3. And there we get 10,060 and 12 cents. And that 12 cents represents the kind of interest on top of interest that we get from the compound interest. So it's 10,060.12, right? So it's not as simple as just adding on $20 every month. it's a little bit more complicated because we have this extra little bit of change because this is compound interest, which is not a big deal after 3 months. But compound interest can be a big deal after 30 years. Okay? So anyway, but we'll get more into that in chapter 4. But the long story short is we're increasing by 0.2% each month, and so that is exponential growth, right? So because it's not linear, we're not just adding $20. We're getting a percentage increase each month, an increase of 0.2% each month.